Da, 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 da. Yes. Oh yeah. I like how it's. Oh, whoa! I'm hearing myself. Okay, mentor. Yeah, sorry about the description. There is an Atari ST aspect, but it's not only for Atari ST what I'm doing today. It's something that I'll be doing for any or every piece of retro hardware. And that is designing this. Take it all in. I'm saying take it all in just as a kind of way of distracting you from while I'm sort of trying to set my settings to see why is it saying next Atari ST project. My next retro hardware project layout. How about that? That's a bit more accurate because I'm going to be laying out this PCB right now. Connect your retro hardware to the interwebs. Done. Save. Oh, I don't even know how you save that. Well, I hope it saved it anyway for those joining this later and going, what is he on about? Although I could... You wondered what the noise was about watching another video, Jared. I don't know. What noise? The noise, me being some noise. Right, so this is my design. I'm just going to sort of very loosely cover the basics of it, or the basic premise of it, and then I'm going to flip over into board creation, and you can see I've already no, I've not really done anything yet actually, and then lay that out, and hopefully I've decided to simplify the board somewhat so that it's feasible to try to do it on a single-sided PCB, and if that doesn't work out then it's going to have to be a double-sided, and then I'll add more stuff. If I'm going the double-sided route and have to get this made outside, then I'm just going to go, you know, add way more ports and, you know, add more eventual things on there. So a little bit of background there. I'm basing this on these small little Wi-Fi modules. In fact, let me get it out of the bag. If you've seen any of the earlier Backoffice videos, I did cover them once. This bloody Ziploc has been a git, so I'm just going to cut it. Here we are. They are quite teeny. So tiny, so tiny. You can see there's my finger for reference. So it's about the size of your fingertip. And these are the ESP8266 chipset. So it's basically a system on chip for wireless transceiver with TCP/IP and embedded Lua and a whole bunch of GPIO you can use. So it's a pretty powerful tool as a development tool. So that's why sorry, I was distracted by the stream. We should talk when you are done with the stream. Okay, Jared, we'll talk when I'm done with this stream. We can talk during the stream if you like, and this is the heart of this module. And you see I've got this thing here saying it's module reprogramming, because I want to make sure that, because I've got big intentions for this module, you know, as it stands, you might be able to get your computer on the internet when this board's done, just as is, factory firmware. But when I'm done with this, I intend to totally reprogram this to add way more capabilities to it, because I need my retro hardware to be able to do a little bit more than just the basics, and that's what that's for. So I've added this module reprogramming lines and things here, and I'm going to make sure I'm going to try to do some research to just see how you know, some of these pins and things are necessary to do that. So I've got my power supply here, which is a 3v3 power supply, just a simple little surface mount regulator. I'm going to be getting power to this board via either a USB, and you can see I'm not using the data lines, I'm just using the ground and 5 volts, so they're coming in regulated. And I'm also going to add just a jumper as a pin header. I was considering, I'm toying with the idea of adding a DC jack, but DC jacks are quite bulky, and there's the danger that you can always plug in something into the DC jack that's too much, like a 20-volt thing. And the last thing I want is to not just blow up this board, but also blow up your precious vintage computer. So that's why we don't have a jack on there. We're just using USB. We also have here, this is a deprecated chip, and we're using them because I've got a bunch of them basically, and these chips are hey Falcon 030, hi. They're deprecated, but they're basically chips to convert the levels, or the TTL levels, because you're interfacing with old hardware that needs the plus and minus 5 volts technically. And all modern hardware barely manages to do 3v3. Some of this is 1.8. So this is to convert the levels into the old school hardware. And as I say, it's a deprecated chip. You can actually achieve this through other forms of trickery in other chips, and it's quite an expensive chip now. So that's probably something I'll be designing out at some point in the future. But there's no point doing it right now. It's good enough for now for experimenting. And this is a reset switch to just reset the board, and that's most of the functionality there. And if we go further down here, this is where the rubber meets the road, as it were. So this is your effective serial port. So your retro console is going to see the hardware the same way it would have seen a modem back in the day. So if you're on your Atari ST, you would load up Kermit or Minitel or Minicom. I can't even remember the name of the application I used to use. And that would allow you then to use the Hayes command set. Remember ATDT and all of that jazz, to call up a BBS. So you'll be doing exactly the same things here, but you have an additional AT command set for wireless. So you're going to be using AT commands to select your SSID and your WPA key and things like that. So your system will just see it as an old modem. But in reality, you're actually going on the internet via Wi-Fi with it. So that's the logic here. That's how your computer is going to do it, PC or otherwise. And what I've done here is I've actually done a PC serial layout for the moment. This is the 9-pin, the DB9 PC layout, which is a female port, because this is a peripheral. This is a slave, effectively. But what I've done is I've added all the additional pins you normally get. So you see all the DCD and DTR, ground, all these other annoying ones that some of these old computers need, because in modern computers generally you can get away with TX, RX and ground, and you just leave all the handshaking, everything to software. But some of the old school hardware needed certain things set. So I've got these solder jumpers here ready to go. So if you're using a PC, you generally hook up all the DTR, DCD and DSR together, and the RTS to CTS together, and that's basically your null modem. Our hardware doesn't use that, so it doesn't really emulate it. So we're just acting as a null modem. So hopefully that will shut your device up, because if its hardware is expecting certain things, that should close that. And then what I've done is, because we're going to be connecting this to an Atari ST or possibly Commodore 64, VIC-20, TRS-80, absolutely anything, we're going to need to have all of their different variants of serial ports. And think of something like a Spectrum Plus 2, which uses a I can't remember call it, like an not an RJ11. It's a weird one, a bit like the BT plug, for example. So those are really odd. So what I decided to do was put down this JP2, which is a pin header effectively, so it can act as a daughter board. So for testing purposes, we're going to have the PC port as standard, and we're going to have a pin header. The idea being you can probably get adapters for a PC port to anything else. So you could definitely get an Atari ST 25 DB25 to a PC DB9 adapter, for example. If not, we'll be able to make daughter boards here with the adapters on it. So it's not a big deal. And if you're lucky, you might only need just pins 1, 2 and 3 of this. So I've laid out pins 1, 2 and 3 ground, RS, well basically ground, TX and RX, just consider them that. And if you're very keen, for example, you could solder these straight into your computer. So my intention really isn't to run this on my Atari ST externally. I want to solder this internally anyway, so I'm going to just try to hook up these pins and the power lines internally to it. Now, something I've just deleted from here is a big connector, and it was a big connector hooking up all the spare GPIO, because you've got a spare SPI bus and you've got a spare analog to digital converter input here, and a whole mess of general purpose I/O lines that we can use. Ignoring these three here, because these three are kind of dual purpose for reprogramming, so I've just reserved them only for programming. And in the future, if we're definitely going forward with a production board which is double-sided, I'll add those GPIOs back in, and then that way, when I modify the software on this device, it'll be able to do other things. And I'll just give you an example of that in a minute. After, let's have a quick sip of my old coffee here. Wet my whistle. The other things you could do, for example, you could hook up the analog to digital converter into some hardware on your device, so you could measure power or voltage or a switch on your Atari ST, or maybe we could use it to measure when something comes on. So when your Commodore 64 is booted up and it's in terminal mode or something, it could tell this module to turn on, something like that. GPIO can be used for any on-off, so you could have additional LEDs or other hardware that you want to be able to turn off. Again, you'll be able to turn it on and off from your Atari or your retro computer, because you can just run commands in your terminal this will pick up and activate on. And then, of course, you've got here a whole SPI bus, as well as potentially another couple of GPIOs, although it says here there's some sort of caveat about that, but I'm not really too bothered about it. But you've got SPI here, so you could have a whole host of sensors being hooked on this. So it's a powerful platform. It's going to be good. So I think without further ado, let's start thinking about how we're going to lay out this board. And I've just sort of kind of shimmied some of the components up. Now this is going to be a tricky one. I know it looks like quite a small board, and indeed, let's hope it is. But there's going to be a little tricky caveat here, is because I'm trying to lay it all out single-sided. So I'm still using the free version of Eagle, which has a bunch of limitations on board size, but I'm hoping they won't get in our way too much. I'm pretty sure they won't. If we manage to lay out a Booby Cortex on this, I don't think we're going to have a problem laying this out. Yes, so that's our level converter. That's our pin header. There's our little module, and it's tiny. Again, if we did a dual double-sided board, imagine how small this will be if we replace that through-hole component with surface mount. You'll be able to just put that on the back, and away you go. It'll be actually quite tiny little dongle there. Hey yo, Mind ST or Mind ST? Not copyrighted. Sunny Saturday. Hello. Yeah, it is sunny. It was thunderstrike earlier, but now it's definitely a lot more tolerable. So I'm just going to see what we can do. We've got here, this is our boot jumper. That's to put it into firmware boot mode, which hopefully we shouldn't ever really need. We do have a through-hole component. There's not really... Oh, Mindist. Okay, Mindist. So just let me have a quick think about this. Where would you expect that chip to be? I kind of think we could if we could just shoehorn it in here, that's going to be good here. And these are those little jumpers we had to do with the, setting up the serial... the serial null modem sort of links. Greetings from Portugal. Hi, Zubels the Purple. I have come for your Zubels. Oh, this regulator is so dinky. I've got to check the specs actually. It might not quite be beefy enough. Do we have a data sheet? We have a data sheet. Here we go. Data sheets, does whatever a data sheet does. Spins a web, Tells you the standby current. It tells you the power down leakage. I want to know your juicy current. It's going to be quite a lot actually, I should think. Oh, this is it, is it? Okay, worst case scenario, 215 milliamps. So what we ought to do is just check that regulator. If you're doing this yourself, just do it like me. Just lay it all down randomly and then check it after you've already laid it down. I need to check our regulator data sheet. AP2202K. There we go. Oh, it's not good. It's only got 150 milliamps, and we need 215 milliamps. So we're going to have to swap that out. Bastard. Good. Good. That's a good thing. It's good we found it, though. 805. Regulator. Do. Well, I mean, that looks good. Burr Brown. Just going to have a scooch down to the SparkFun library because they do tend to have some quite good components there where they've just pretty much gone with the whole, you know, it seems to have the most common components you can get a hold of. SparkFun. That's the connectors library. Blopto. Hello, sir, Mr. Methanoid. I'm just going to go for that standard Burr Brown one. That's going to do. It will do. That's going to do, pig. Most regulators and things like that will just be the same. I mean, if it's an SO223, yeah, I mean, it's fine. 800 milliamps. I thought I saw somewhere fly up there. Bang. So I've got to relay the power supply ever so slightly. I think there is a function here to change the ends. Invoke text wire circle bus net. Or just don't bother. Right, so the V in. Ground. V out. So we want a 3v3 regulator here. So if you're specifying it, we're already at 5 volts. We only need 3v3. Get your ground in. Get your 5 volts. 3v3. And if you fancy it, you can keep hold of all those caps. Let's just delete that old one. Don't need that. Don't need that. Don't need that. Don't really need any of that. But that's fine. We've made a space. Just plop that bad boy back in. Here's a little trick. Look, put it there. And then select that again. You can scooch it over, join that wire there. And just double select, make sure it's selected, scooch it back. See, it's nicely connected up. Let's save that. Back to the drawing. And there's our new beefier regulator. So they're still pretty tiny though. They're quite minuscule. Don't have one to hand, but you can fit them in most places. That'll be fine. So just to show you, we've got our reset switch again. That's a tack switch, so it can kind of live anywhere. USB port for power. Pin header for power. There's our LED. We've got power LED. It just comes on when there's power on the board, so it's nothing too too sophisticated. So we can just put that anywhere. I think we're going to put that right there. I'm just trying to kind of line things up a bit. Seeing as that's power, it could be oriented that way off the back of the board. A solder jumper related to programming, but not necessary. It's probably going to be closed in operation. So I've just put it in there just to sort of, just in case it's needed. get our resistors all in line. A few more resistors. So that's connected to our GPIO and the rest is connected to ground, so that could kind of live among this bundle. Again, we just move these up, just keep the resistors in line. Another resistor. Although that one is actually connecting on that side of the board. Just leave that there. We can go there, get our switch in. That's somewhere over here, and that's somewhere over here too. Good. Just gonna lay those out. I'm not really paying any particular attention to spacing between these components. You can see they're all quite close, but I think you would find in operation that that jumper would be a bit close to that resistor, so if you can, just give it a bit of room, because it's something that you need to use your fingers on to move in and out. You can put them as close as you want almost to solder jumpers, because solder jumpers don't take up any physical room at all, because they're obviously just printed on the board. Right, starting to get a sort of feel for the size of the gadget. Wi-Fi. Retro Wi-Fi. I really hope I can get this laid out in a single layer board, because if I can mill this out right now and make it. I'll be using that today. Sorry, Methanoid, you missed the beginning. The reason is because this isn't really only for the Atari ST. I've decided, because I've got Spectrum and I've got ambitions to be owning a Commodore 64. See you later, copy not righted, sir. That I want to make sure it can just sort of work on everything. So that's the simple answer. Let's get our reset switch there, a bit of room out of the way. There, that'll work. So the idea is, yeah, you can use different personality boards for different computers, and I'm designing it for the PC serial port because this PC serial port is pretty standard. And you can get alternative interfaces, can't you? You can get adapters for PC stuff. So I'm going to go for broke now and tell it to try to auto-route a bottom layer. I don't suspect it'll do much, but let's try. It's got 90%. Normally, if it gets something like 90%, there's always a possibility then you can kind of hand route the last bit yourself using human skills. And I've just noticed actually in the streaming window, I could move the whole image to the left a bit, and then it wouldn't obscure the chat, or chat obscure it. Now that doesn't look to me like a board that's been routed single-sided. That looks to me like somebody's made a mistake. So let's rip that up. Ah, top. None. Nada. No top. Unreachable. SMD pad. Oh, okay. Well, continue. No. Make everything from the bottom then. I've just realised something. Maybe I want to put the DS275. I need to put the DS275. See you later, Dean. On the back, so that they can we don't have to mess around with these as vias. Just thinking about it. Good. In fact, let's cancel that because there's no point right now. The reason is we want to flip these around. So Spider-Man, Spider-Man. Mirror that. Mirror that. So this is basically putting it on the other side of the board. This one is less issues. This doesn't really need to be mirrored, does it? It's just a pin header, but it's fine. I was only putting it around whichever way is convenient to the pins. How about that? And if we're going to do that for those two, we're going to mirror these as well. Mirror. So basically, this is laying it out as in a way that makes it it's almost like as if all the hardware is on the bottom of the PCB. So there'll be very little on the top, which is kind of cool because it gives us a big area for printing something. So we might move, if it was a double-sided design, we might move the button to the other side, for example, but that's fine. Save that. Let's have another go, auto routing. Top. Nice, sweet, sweet coffee. So if you're ever doing this yourself and you again want to try to get it single-sided, sometimes the use of certain amount of through-hole components can be beneficial. So if you've got, for example, some through-hole resistors, some big ones, you can run traces normally underneath them. You can run a bunch of traces in between the two pins of the resistor, whereas surface mount ones, you don't really have that opportunity unless you start putting down much bigger ones than I have here. In operation as well, if I don't hook up the reset switch, to actually get this to work with my computer right away, I can just put the module down, IC1, the DS275 chip, and the serial I/O, and that should be it. Maybe something for power. I don't really need to hook up any of these resistors or the power switch, so that's pretty neat too. I do. It can't figure out the auto routing quick enough, so yeah, quantum processing needed. So let's see. We've not got that much it couldn't do really. So even though we don't really want to make a double-sided board, we could have basically a solder jumper. So we could run a trace through the board on the back, but then actually just put a wire in. I mean, that's definitely doable. So let's leave that one for now. Let's have a look here. So if I really wanted to make my life basically simpler, I was going to say make myself simpler. I don't think I could get much simpler. I could just opt to remove one of these connectors, remove the pin header or remove the serial port. Well, I think I will do that right now because I want to get a board I can make today. But the serial port, look at it. It was so tricky to lay out because you had all the pin numbers, whereas that one is just all laid out linearly. I haven't learned in Eagle how to actually just turn off an object either at the moment. However, this pin header will be so nice to route, won't it? How about I use snipping? Hang on, I'm such a moron. Save as. I'm going to call this simplified. I wish I did that before I erased my other one. And then I'm going to delete the bits I want to make the whole simplified version. So we don't need any of that. That'll just give us enough to get it out onto the computer. And then I can test it. Boom. Let's have a look now. Much simpler. Much simpler. So drag that over again. Let's rip up that bad boy. Probably ought to, I could shimmy that whole board down a bit as well. I'm trying to think what the dimensions of that are. It's pretty tiny. It's I can tell you in a moment. Don't give that bit more. Be a bit more generous with that USB port. Well, if I look at the dimensions, it's in inches it seems, so it's nearly about 2 inches, 195 it's saying. I would have thought it's a bit smaller than that, but maybe it is, nearly 2 inches. Let's go for it. Get on with it. Don't know what it's showing us now while it's doing it. 84%. So there's a little trick on that one, isn't there? The first one it can't. You could just sort of say go around this way. Also, these traces are a little bit thin for hobbyist routing, but can sort that out later. Right, so that one's kind of doable if I do a little thing like that. This one, just seeing if there's any obvious way of rearranging any of those bits. Look at that 3v3 trace, how tiny it is. I just get vaporized instantly. That's a weird one. Why? I don't know why you're having so much trouble doing that one. I mean, okay, I'm putting it with massive traces, but I just want to give you an example. It could have done that, so that one shouldn't be a massive issue. That one, could it do anything? It's not really a convenient way of jumping over. So I'm just going to try rearranging some of those resistors at the bottom. I think they will allow it to route if I can clear those over. I'm just wondering what would happen if I just put that in the other side. Hello, sir. Atari staff room. Quick, tidy up. Tidy the staff room. The teacher is here. Just making these look a bit more pretty. There we go. Bit more space. Have another go. I mean, sometimes it's worth just playing around like this rather than spending loads of time. Just move a few bits around, see if you get an improvement. Look, 89%. A 92% though, look at that. That's looking pretty bloody good, isn't it? 92%. Let's see how we can get that last couple of traces on it. Don't know, Jared, the resistors at the top don't seem to be giving us any grief at the moment. USB port though is. Yes, indeed. The only time you have all of these dual footprint things, it does cause problems. Okay, this is our simplified drawing of at the end of the day, so let's just kill our USB port. We don't need that if we're doing a bit of testing, do we? Ah, what did I just choose? Bugger. Wrong thing. Bang, 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 bang. Get rid of that USB port. Done. Software jumper 1. Software jumper 1. Well, if we're doing our whole, tests, why do we need to do module reprogramming? It's a fair question, isn't it? If I wanted to reprogram it, I could just solder wires to the module legs. Boosh! That's pretty minimal now. Now we're talking proper minimalist. Minimalist. Well, if we're going minimal, why do we need a reset button? Got that feeling that we're going to end up with not much on this board if we're not too careful. Right, so we've got our pull up on the reset. Do we need the LED? Power supply, conversion chip, module. I think we're almost at the as far as we can go, unless we want to start. We can just get rid of the LED, but I don't think we're gonna have much problem with that one. God, there's hardly anything left. Let's get those over here. Let's get some spacing. Sometimes it's just the rotation though. You just don't know how it's going to fare just because of its rotation. I'm going to again shunt this down to the edge of the board because I don't want it to accidentally route around the edge of the board, because that can be a bit annoying when it does that. Let me move those components first. Okay, got loads of room for those. I've got a feeling it's gonna work out. Now I'm just trying to remember from my process. If you remember before, we made that milled PCB, and it's been long enough time has passed for me to completely forget how I did that. I should have wrote down the process. Maybe I did. I'll have to check that. So this module, really, you could almost have the whole Wi-Fi bit sticking out if you want to as well. Give you a bit more Wi-Fi-ness, which means, of course, that we can make the whole board a lot smaller again if we kind of want to, which I think we do. So that you could just have it like that. Just itching to be totally snapped off. That reg is kind of fine where it is. I kind of think we can make the board a bit narrower as well. I don't want to waste time auto routing it right now because it will annoy me and then I'll feel like I make it narrower. Now look at this pin header. We've only got 3 pins on the bloody thing. Do we need that pin header to have so many pins when we got rid of all of the components? Point. Good point indeed. Let's see if we can do a pin swap here. If we think of what we've got rid of, we've got rid of that. That's what we're left with. That'll do. So I'm just going to plop that there on top, and then I'm just going to delete that one. And hopefully moving that around, bang, there we are. I'm getting to the point though here where I could almost just make this on Variboard, and the only reason I'm not making it on Variboard is it's not particularly easy to hook that module up to Variboard. I think we're there. I think we're there really. We ought to flip this. So that is mirrored, is it? Okay, well that's fine. This is that one that needs to be mirrored. Yeah. Flip it to the other side of the board to be consistent across how we're doing it all. Shunt that to an edge. I think that's about as close as we want. I hope I've got some PCB boards. I'm pretty sure I do. Come on now. Let's squeeze these guys up one. See, you could leave these there technically because this chip is actually on the back. But I'm just gonna give it all enough room, just as if it's not. I mean, we again know it's on the back, so you could go pretty close like this if you want to. They're actually touching anyway. What's this 270 and this 4K7? I'll just double check what they're for. I think they're pull-ups. 270, it's the pull-up for the reset, and it's the 3v3 like a chip select. So yeah, I guess we'll leave those. We probably could do away with those as well. Oh, so close. But then that's more even. That's even. I know the module's not quite where we want it. God. It's kind of going to irritate me if I don't do this right. Bear with me. I think that's about as close as you can get it. Good. Let's auto route. Effort. High. Maximum effort. I want you to try hard here. Again, there's no analog component on this. It's all digital signals, so you don't really have to worry too much about any differential lines and things like that. Still having a little think. I just got a warning from YouTube saying that my video is suffering. It's my auto router sucking out rendering power. That's hilarious. That is hilarious. I was seeing a video output low message on my stream health there. Yeah, so we've actually done a lot worse now. I suspect that's because the board has got smaller and smaller and more compressed together. So I have to have a look-see. So this connector might be better flipped that way. By the way, if you're ever auto routing, you can kind of just continue where you left off. You don't have to start from the beginning every time. Come on, get your wiggle on. %81. This module is almost better that way. Think how good it would be that way. I might just do that, you know. God, it's a pain, isn't it, these things? I do have another version of this board, ironically, which has an external antenna, so I didn't even have to lay it this way. But you can see the issue. The reason it's having difficulty is because of all these pins here acting like a wall, stopping it routing through there. So the only other option really is just to give it all a bit more room. Actually, this capacitor and that component kind of want to go together, don't they? Because they're just hooked to ground. Let me just experiment a sec here. Get that up there. I think that'll be better for us as a solution. Let's try that. Let's go for that. Yeah, super speed. I need a better PC. I need to offload the job to a sort of national supercomputer somewhere. %81.8%. Yeah, balls to that. Let's just spread it out. Let's give it some room. Get on with it. If it can't route around this slot, then I'll be a monkey's uncle. Can't quite see which way around that bloody thing is. Looks like a capacitor, but there's only the ground connected. Hang on, C5. Go, Gadget, go. Huh. There we go. That's C7. That's connected. Yeah, C5 wasn't quite connected anyway. Now it is. Nicely spotted. Kind of makes you wonder how many of your designs have sort of little flaws like that you never notice. Bang. Bang. Come on then, I think you're going to do it now. We're getting pretty close. $95. 100. Boosh. Good. So I've got a PCB now that any issue whatsoever, I'm going to have to manually solder cut jumper to get anything working on this, because there's no leeway in the design for solder jumpers or anything like that. Programming headers, but I think it looks pretty good to me. We got it smaller yet? 1.75 inch. Nice. Yeah, bodge wires. I like to avoid the necessity for bodge wires. Retro Wi-Fi. I'm not sure what I'm going to call this board yet, but I'm going to name it as such, the retro Wi-Fi board right now, and then I'm going to call it something snazzy and pithy a bit later. But there you go, that's the board. That's how it's going to work. This will definitely need to be connected to something else. This will be a sort of flopping around board, but there's plenty of room here actually, if you see, for adding a DC jack. It's not a great layout. I'm going to be honest with you, it's not a great layout, but it will be when I do something like that. So if you remember watching the video on the Booby Cortex, and I think I can do the miracle of video. There you go. So that's the Booby Cortex board. So if you remember that stream, how that looked when we were designing it, and then I'm going to try to hold it a bit more steady. There we go. How that ended up. It looks great, doesn't it? That's how you do it. So this board you can see on your screen right now is going to be really not much bigger than that. What did I do with the module? Here it is. In fact, I'm a bit of a moron in a way. I know I am, because I could probably just solder the Booby this to a Booby Cortex and piggyback it. It's already got a lot of the peripherals and things we need. But just to give you an idea of sizing there. So if you can see the module and the board, it's going to be really quite small anyway. It looks huge on the screen, but it's definitely going to be small. And that's it. I'm gonna try to build this one way or another. Either mill out this PCB, which might take a lot longer actually than just making it by hand on Veriboard and using lots of bits of bodge wires, millions of bodge wires, just to sort of get this off there. The only annoying thing with this module is it needs all those bloody pull-ups. But yeah, apart from that, pretty simple. And then the rest of the complexity, again, laying out for the proper board and then adding all the extra GPI and stuff I want, and then everything else is coding on the chip. So if I just want to change the coding on the chip, we're done. So yeah, is there anybody with any questions? Why faux fum? The Wi-Fi faux fum, Wi-Fi of Doom. Yeah, I'll think about those names. But I don't know. I might come up with something. I'm going to come up with something a killer name. But yeah, any questions about this project and how it might affect your hardware or how you might want to use it? Now is a great time to ask. I was planning on this taking about an hour, and it has. So I've got another 5 minutes left. So please feel free to ask any. If you actually have access to a cheap Commodore 64 or possibly any other retro computer, I could be interested, because I'll be needing some hardware to test this on when it's done. So far I've got Atari ST and a Sinclair Spectrum Plus 2. So if there's anything else you think it should run on, if you can have a quick look in your local area, especially if you're in the UK, if you find a deal, because I can't, if you look on eBay and stuff, you don't find deals, but if you look on your local Gumtrees, let me know, and I'll be happy to PayPal you or something some money to pick that up for me. That would be amazing. So one question there, will it be built and online by 8 PM? Well, I would love that to happen. I honestly would. But I'm slightly worried that the Atari ST DB9 connector isn't going to play ball with me, because I'm pretty sure I don't have its counterpart connector on my shelf. So if I do that, I'll have to solder into the Atari ST itself, and that could slow me down. Although, to be fair, it's not even 5, so there is a pretty good chance that could happen. It really could. It's actually a shame to have to use these DS275 chips or equivalent, because not only are they sort of retailing anywhere between £2 and £20 each right now, because they're discontinued and really useful chip, but because it's just an extra chip that's not really doing anything particularly useful, but it is necessary. Interestingly enough, if you've got any experience of the MAX 232, that's what these chips replace. And MAX 232 level converter chips needed a whole lot more additional hardware. They needed charge pump capacitors and I think maybe a couple of resistors, things like that. But These ones will do nothing. Actually, while you're online, Methanoid, you're a good chap to ask this, and hopefully you've received your program GoTech by now. If not, it'll be with you on Monday, I'm sure. How much would one of these be worth? I'm trying to think. I have to gauge the amount of effort I'm going to put into this by the possibility of breaking even or any return. So I'll make one for myself for sure. If it's cool enough, I might make a bunch of them. But I need to get a feel as well how much somebody would be willing to pay to get their retro computer effectively on the internet. So I'm pretty sure there are already some things out there, some modules, but I'm not gonna add or offer too much more functionality than just getting you online. And I'm thinking of creating a BBS, a retro BBS for these things to connect to. So imagine all those BBSs you had as a kid, and Prestel and all those services and things that look like teletext, all that sort of thing. Imagine that, yeah. I want to create a bulletin board system that's delivered via HTTP, but not HTML. It'll be delivering it via a different system. And I'm going to make sure the code on these makes it super easy that they can connect to that system almost by default. So when you power up your Atari or your Commodore, whatever, the first thing it can do is go straight online, hit their website, which is a common BBS, and download like the news page. And the idea being, you can create your own page on that service. So it's an alternative service. You can register to have your own page on it. It'll be like a top-level DNS. And it'll have its own API for programming it. So you can have your Doors games. We can play online mud games and everything. But any retro computer will be able to do it because they'll all have that capability of running the terminal. So as long as you've got enough characters, we can make the game 40 wide or whatever it happens to need to be for a lot of them. We could have a mud game, and you could be playing on your Commodore 64 and I could be playing on my Spectrum, and we're going to have a blast. So that's my ultimate plan for this hardware, and I kind of think it's cool. I want to be able to have my computer in the corner in my lounge, and I don't really use them to play games, but I would use them to chat to people and go online and browse and just play with it, get the weather services. The exact same way I used to do when I was a youngster with my Atari ST and its modem. So I think that's kind of where I want to be with it. And I can see in the comments, yeah, there are some systems out there. I'm pretty sure there are, because you don't have to do much. I talked about it in a previous video about shoving one of these Arietta G25s or Raspberry Pi Zero, but that's kind of not quite what I want to do with it. I kind of want to get it. I just want to make it simple. I want to bring it down a level. I want to make the whole interface, the whole thing is going to be retro, right? It's just going to be simple. All us gamers can just hang out online in this space, and it's a fixed sandbox. You know you're not going to get animated GIFs. You know you're not going to get 200 things that your retro computer can't do. Yeah, not like a Raspberry Pi, which can almost do a lot of stuff your PC can, but do it craply. This thing will say, no, it's doing this amount of stuff in a retro way using the exact capabilities of most of the machines at the time. And that's that. The same way if you accessed a bulletin board back in the day, that everybody more or less with the same similar hardware could access that bulletin board and experience it in the same way. And that's it, really. I can see some comments there about some hardware, something about DB25 plug, bloody blah. I'm going to check out any links you've sent me, guys. I know you're tweeting me. I can see Twitter and stuff flashing on that. Yeah, I'm going to look at what other people do, but again, I'm probably just going to roll my own as I do, just to sort of satisfy myself that it's something I can do. But we'll see what features they give you. But this thing, when it's done, I really hope that it won't be. I've got a ruler in front of me here, just a sort of steel rule. I'm going to aim to easily get it within 4 centimeters by 2 centimeters. I will be very disappointed in myself if I don't manage to achieve that. Probably less, actually. Probably less, depending on how it has to interface to other things. And I might not even use this module. So I've got a module on here. Obviously, I'm using a module on this board, so I'm like a motherboard for this module. But I might mount this chipset directly on my own board, so make my own version of the module. Anywho, I hope that's been of some sort of entertainment to you. I think you've been a very gracious audience, not swearing and cursing me out like usual. Please, like, share, subscribe. Feel free to comment down below. Buy me a coffee on Patreon, or just keep an eye. If you see anything in the back office shop you fancy and you can afford it, that's great too, and that really helps. Again, keep me in coffee and baked beans. Go have a wonderful Saturday evening, and have a wonderful Sunday. And I'll post updates on this again, probably on Patreon and Twitter if I get anything going. If I'm really super excited, I might start a stream later and stream about it, but we'll see about that. As ever, guys, much love and thanks for watching.